Dear learners, Namaskar. I am Dr. Shweta and today we are going to continue our discussion on attention and perception part 2. The objectives of today's program are to explain the perception of shape and illusions as well as to understand the problem of space perceptions and the cues that are used in it. Let us begin with the determinants of figure ground organization, that what helps us in organizing the figure and ground perception. The Gestalt psychologists in Germany, principally Kohler, Kafka and Wertheimer, proposed that the brain has the innate capacity for organizing perceptions. They identified the laws of organization which determine the way in which we perceive the objects that are around us. They maintain that electrical fields in the brain are responsible for organization of perception. They were also interested in exploring figure-ground distinction, that is what makes figure stands out against a background. So, they are of the opinion that there are some laws of perceptual organization. Let us discuss about these laws one by one. Number 1 is good form or law of pregnance. This law states that perceptual organization will always be as good as the prevailing condition allow. The simplest organization requiring the least cognitive effort will always emerge. Pregnance. This is the first law of perceptual organization. Pregnance means that we perceive the simplest organization that fits the stimulus pattern. In German, Prägnanz means clarity. So, laws of Prägnanz are laws of clarity. The most common translation is the law of good form. A law of Prägnanz identifies an organizational tendency, a way in which the human brain decides that things go together. The second is the law of proximity. That means all the stimuli that occur together in a space or time will be organized together. You can observe in the following figure that 3 groups of 2 vertical lines are there. You will find it difficult to see 6 individual lines. The next law is the law of similarity. Other things being equal, elements which are similar in structure or have common characteristics will be grouped together. For example, in the following figure, 5 squares are there, 5 triangles are there and 5 circles in columns are grouped together. That means you have a tendency to group the similar looking objects together. Closure is the next law of perception. Closure. An incomplete figure will be seen as a complete one. For example, the following figure is consisting of incomplete lines that have gap in them. It is perceived as a triangle despite the fact that its sides are incomplete. That means we have the tendency to close the sides or the ends. A closure-like phenomena yields subjective contours. In this figure of triangle, you observe that the triangle does not exist at all. That is, the lines forming a triangle do not exist. Still, it is compelling to perceive a triangle in this figure. Now, let us come up to the next topic, which is illusions. What is an illusion? Illusions are misperception, as the name suggests, and they result from misinterpretation of sensory information. Illusions are known as false perceptions. For example, if there is a thick rope that is lying on one side in the dark, it could be perceived as a snake. Illusion is a normal phenomena which is perceived by all human beings and animals. You must have experienced moon illusion. What is a moon illusion? You might have observed that the moon in the horizon looks far bigger in size than moon in the zenith, that is when it is at the top of an individual in the sky. We know that the retinal image of the moon at the horizon or zenith is the same, that is moon being at the same distance from the earth when it is at horizon or when it is at the zenith. However, its perceived size differs a lot. Why it is so? One explanation takes into account the size-distance relationship. Helmholtz long back suggested that the judgment of size is related to the judgment of distance. For example, the retinal angle being constant. If the judged distance of an object is more than actual physical distance, that is what you are judging is more than what is the actual physical distance, then the perceived size will also be larger than the actual physical size and vice versa. It is contended that with retinal image being the same, the perceived distance of the moon in the horizon is more than the perceived distance of the moon in the zenith. Thus, the perceived size of the moon will be larger at the horizon than the zenith. Geometrical illusions. There are quite a few illusions that can be demonstrated by drawing some lines. These are called geometrical illusion. The most famous is the Muller-Lyer illusion, in which you can see that there are two lines, but one line or one figure is perceived to be greater in length as compared to the other. So, this is known as Muller-Lyer illusion, although the size of the two lines, arrow-headed lines, are same, but to the perceiver the one is perceived as greater to be in size than the other one. Perception of space. When we talk about perception of space, it refers to the perception of size and distance. The problem emerges from the fact that the image of the three-dimensional world is projected on the two-dimensional retina. This raises the question, from the two-dimensional image, how do we perceive the three-dimensional world? Or in other words, how do we perceive depth and distance? The problem of space perception is depicted in the following figure. It can be observed from this figure that points A1, A2, A3 on the line of sight fall on the retina at A. Similarly, those of points B1, B2, B3 fall on B on the retina. That is, the image of the external object on retina is always inverted. That is why A's projection is on the opposite side and B's projection is projected on the other opposite end. The available information on the retina can only indicate the direction of these points in space, but not in any obvious manner about distance from the eye. That is, the location of A1, A2 and A3 or B1, B2 and B3. However, in our day-to-day experience, we know that our perceptions about the depth and distance are quite accurate. If a judgment about the depth and distance were not accurate, we would be colliding with the objects in the external world. We cannot drive bicycle or scooter if our judgment of depth and distance are inaccurate. The problem is that how do we accurately perceive space, that is the depth of an object or some place or the distance of an object from two-dimensional image on the retina. That is, only the two-dimensional image is projected on the retina, but then also we are able to perceive the world in the three-dimensional. You will shortly find that the perception of space is possible because of the various cues that are available to us. Before we talk about various cues, it is good to have a clear understanding of various terms that are used. Number one is distance. This refers to the absolute spatial extent between the observer and the object, and it is represented by capital D. In the following figure, there is corresponding to the physical distance, there is a perceived distance, sometimes referred to as the apparent distance also. The second term which is related to these cues is depth. It is the relative spatial extent between two objects as viewed by the observer. That is what you view. What is your perception about the depth among two objects? For example, the relative extent between the two trees as viewed by the observer in the following figure can be different. Corresponding to the physical depth is the perceived depth. That is, what is the actual depth and what is the depth that you are perceiving. The depth perceived by the individual. The next term which is associated with the different cues is known as size. The object has a physical size that is out there. The individual perceives this. It is called perceived size and is represented by capital S. It is interesting to understand that we perceive depth and distance with the help of various cues that are available to us. These cues may be divided into three categories. Number one, the non-visual cues. Number two, the binocular cues. Number three, the monocular cues. We shall discuss about these cues briefly. Let's first of all talk about the non-visual cues. That is, accommodation and convergence are the two non-visual cues. These cues are called non-visual because they do not emanate from the retinal image, as is the case with other cues. Let us talk about them one by one. First of all, let us know what is accommodation. Accommodation, what we call focusing in camera. In the case of eye, we call accommodation. The image of the external object is focused on the retina with the help of lens in the eye. The lens is adjusted by ciliary muscles to focus far and near objects on the retina. The ciliary muscles changes the convexity of the lens so that the image of the object is clearly focused, and this process is called accommodation. If the object is relatively at a distance which is more than 2 meters or so, the ciliary muscles is relaxed. When the object comes nearer and nearer, the muscle contracts more and more, making the lens more convex. The degree of contraction of the ciliary muscles signaled to the brain through kinesthetic impulses is a possible cue of distance. That is, if the object is farther away from the viewer, the ciliary muscles is relaxed, and when the object is nearer, the ciliary muscles is tense. The extent of contraction in the ciliary muscle fed back to the brain is the cue of accommodation. However, research indicates that accommodation is a weak cue of perception of depth and distance. Now, let us talk about another non-visual cue which is known as convergence. Convergence. When you read some text in the printed line, you converge your eyes with the help of 6 intraocular muscles located outside each eye to bring the image in both eyes to fall on the fovea of each eye for fusion and clear vision. The extent of convergence achieved is signaled to the brain, and this provides a cue to distance. For example, if the object is nearer, the angle of convergence will be large, and as the object goes farther away, the angle of convergence decreases. For objects at a far away distance, the eyes are more or less parallel. The extent of convergence achieved is fed back to the brain, and it is a cue to distance. Again, research indicates that like accommodation, it is a weak cue of perception and distance. Let us talk about another category of cues that help us in perceiving and organizing the information in the world around us. These are known as binocular cues. Binocular cues, unlike the two cues, that is accommodation and convergence, emanate from the retinal image itself. These cues are of two types, double images and binocular disparity. Let's talk about them one by one. Double images. We have already discussed about that when we fixate our eye on an object in space, fusion takes place and we see one object. However, when we fixate on an object, all other objects nearer or farther than the fixation points fall on the non-corresponding points and produce double images. You can try this phenomena as well. Take two pencils, hold them vertically in a line in front of your nose, one nearer and the other farther away. Now, fixate your eyes on the nearer pencil. The image of this pencil falls on the corresponding point as you converge your eye and accommodate, and fusion will take place. You will be able to see the pencil. However, the image of other pencil will be double as it falls on the non-corresponding points and fusion will not take place. Similarly, if now you fixate on the farther pencil, the image of the nearer pencil will be doubled. However, the double images you have just experienced are not similar in nature. The first will be uncrossed double image and the second will be crossed double image. The phenomena just explained can be seen in the following figure. Thus, when we get uncrossed double images, the object is farther than the fixation point. On the other hand, when we get crossed double images, then the object is nearer than the fixation point. Binocular disparity. Objects that are nearer and farther than the fixation points project their retinal images on the non-corresponding or disparate areas of the two retinas. Greater the distance from the fixation point, greater will be the binocular disparity. That is, disparity increases as the distance of the object from the fixation point increases. This retinal disparity is the possible cue about the distance of the object from the fixation point. Another category of cues is known as monocular cues. Monocular cues are also called pictorial cues because they include the kind of depth information found in the photographs and paintings. These cues are extensively used by artists in their paintings. There are different types of monocular cues. These are interposition, aerial perspective, linear perspective, lights and shadows, familiar size and texture density gradient. Let us consider these cues briefly. First of all, interposition. When an object A partially blocks another object B, the object blocked is perceived farther away than the object blocking it. You can see it in this figure. This cue develops early in children. The next is aerial perspective. When you look at the buildings in the city, buildings close by look clearer and their boundaries, that is contours, are well defined in comparison to distant ones which look grey and hazy. The buildings, trees and other objects that look hazy are perceived far away in comparison to which look clear. Linear perspective. When parallel lines recede into the distance as railroad tracks, they converge towards a point in the retinal images. It is depicted in this figure. Light and shadows. We are often aware of the source and direction of light. It is generally from above as sunlight. The shadows cast by one object on another can indicate which object is farther away. Familiar size is another monocular cue. Because you know the height of your friend, you can judge the distance at which he or she is standing. This is possible because we always store the memory image of the object that we see. When we look at an object which is away from us, we can interpret the distance from the retinal image by taking into account the familiar size. Texture gradient. It is another monocular cue. Look at the plowed field. The nearer surface looks rough, and as we extend our vision farther away, the texture gets finer. Similarly, if you look at the grass nearby, you will be able to see the blades of the grass clearly. But as you extend your vision to a distant point, the ground looks as if painted green and the blades of the grass are no more visible. This texture gradient is a cue to distance. The objects lying on a surface that look fine and smooth in texture are perceived at a greater distance than those objects on a rough surface. So, this was all about today's program, in which we talked about the laws of perceptual organization and different cues. We shall meet and continue our discussion on attention and perception in the third part. I hope you have understood well the concepts of today's program. Thank you.